equals to 0, or the second number, x plus 3, equals to 0. And so we're going to look at both possibilities, and actually it shows that we have two answers. When we solve this, add 1 to both sides. I get 2x equals to 1. Divide by 2. X is 1/2. And then on the other part, subtract 3 from both sides. X equals -3. So my answer is x equals to 1/2 and 3. So there's our answer. These do check in the original problem. For example, 3. If I put 3 up here, this would be 3 squared is 9. 2 times 9 is 18. 18 minus 3 is 15. And, oops, I made a mistake, didn't I? I didn't do that intentionally, but when you make a mistake and check your answer, then you're going to find that most likely that you made a mistake. My mistake was I didn't write -3 here. All right, so I really did not do that intentionally. Let me try that again. -3. -3 squared is 9. 2 times 9 is 18. 18 minus 3 is 15. -5 times -3 is also 15, so that balances out. If I plugged 1/2 in, oh, it's a little harder to figure. Let me see. 1/2, let me make room and I'll check 1/2. 2 times 1/2 squared minus 3 should equal to -5 times 1/2. Well, 1/2 squared is 1/4, just 1/2 times 1/2. -5 times 1/2 is -5 halves. 2 times 1/4 is 1/2. 1/2 minus 3, well, 3 is 6 halves. And so 1/2 minus 6 halves is -6 halves. And that also checks. All right, well, very few people make mistakes from here on down as far as, once you separate these linear factors and set them equal to 0, not many people mess that up. Then a lot of people screw up these problems because they don't check their factoring. So I would say, as long as you're checking your factoring, you probably don't need to check this, unless you want to check these into here, which is a good idea. That would have caught my mistake. But the other error in this particular kind of problem is sometimes people will, when they bring these together, if you don't write it in descending powers, let me show you what it looks like. So if we add 5x to both sides here, if we write it like this, then you're going to have a heck of a time factoring it. And even if it factored, you would still get a, well, I mean, you could factor this correctly, but it would be difficult because we're all accustomed to factoring when the quadratic part, the trinomial, is written in descending power. So careful there. I've seen people misfactor these because they're using, for example, they may have 2x, x, 1 and 5 somehow, because 1 times 5 is 5. And they'll put something in here to make it work. Well, that you can check that, multiply it back. It does not work because you don't get a -3 in the middle. And you don't even get 5x, you get only 5. So some people are extremely careless that way. So let's kind of summarize all this. When solving a quadratic equation, first make sure that you've organized and simplified everything on one side and it equals to 0. If it doesn't equal to 0, then you can't use the zero product property to solve the problem. It's going to be much, much tougher. So you need to simplify it. Everything goes on one side, equals 0. Descending powers. Factor it. Check your factoring. Set each factor equal to 0 and solve those. And so this is solving quadratics by factoring. Now, Yeah, the purpose of this chapter is to show you what happens when you can factor. How do you solve these? And so we'll get there in the next couple of videos.